recording start. Morning से मेरी सरप्राइज चालू हुई रात तक वन बैक टू बैक बहुत एक्साइटेड तो लेक्चर देखिए इतना ज़्यादा एक्साइटेड मत हो मैं very excited बोल रहा था नींद तो सुबह से दे यूट्यूब में सर्च किया ऐसे टाइप करना तो impress your partner चाहो तो खाली अगुवाई कर देना। हमारा बुरा लगना करूँगा, बाइक को खुद ही खुद अलग बढ़ जाएगा बाइक में करो।
क्यों आ रहे हैं मतलब
जितना सेव सरकार में निकाल रहा हूँ मैं मेरा देखो कितना करके आदमी देना तो 2 महीना उससे बड़ा बन चुका हाइट में। इसकी हाइट में 2 महीना से बन चुका कर चुका हूँ। कम से कम 3-4 महीना बना लो। इसकी डिसाइड कर दिया है कल शाम के लिए।
अच्छा शाम को कौन जाएगा?
मुझे क्या पता, मुझे कितना हो
है
तो मैं ऐसे रहता था सुबह मॉर्निंग ऑफ डे सरप्राइज में गए बताया तो फिर बोले कि एक और है, फिर ऐसे करके कुछ कुछ ऐसे होता है फुल डे फन एक्टिविटीज। फिर रात को कुछ पढ़ा टमाटर इतना तो नहीं खाओगे तो क्या मतलब, मुझे पता था मैं कुछ ना कुछ तो ऑर्डर किया ही होगा। तो मैं तुम्हारे बर्थडे के लिए या वैलेंटाइन डे के लिए दूर जाके 7 दिन पहले से ऑर्डर कर दिए तो मैं क्या जी अच्छा लगता है क्या जी चाहिए।
तुम्हें क्या अच्छा लगता है?
तो तुम्हें बताओ
तुम बोलो
क्या
ना।
अच्छा लगता है फिर वो टाइप दिन भर मेरे साथ है तो तुम्हें पता
बोलो तुम क्या चाहिए?
है मैं सरप्राइज करना है झूठ बोल रहे हैं ना, मुझे पता है मैं गलत सॉफ्ट डॉग मुझे पता है
गेस करो
पता नहीं
तो फिर
कैसे कैसे वो सरप्राइज है ना,
नहीं आया।
तुमने गैस किया तो फिर मैंने क्या मांगा
तुम बोलो ना। करो
कल बोलना कल जो गाँव में और गैस करवाना
जा
तब मैं करूँगा मैं
नहीं
कैसे कैसे करूँगा सामने रहेगा तो मैं कुछ मैं भी तुम्हारे रखते से तुम बोलो ना आज मैं करूँ ऐसे करना आज तो मैं ना वाला फैलाऊंगा तुम करना नहीं अच्छा चलो मतलब
I have a suggestion regarding the problems of the previous assignments. Sir, am I audible?
हेलो
लो
हेलो
Hello, am I audible? Hello, somebody was saying something. Hello, am I audible?
Yes.
Yeah, so okay. So somebody was asking me something. So can you repeat your question? No? Okay. So let's begin with the today's session, and I have given you my introduction in the first class, that how we'll run this course and how we will move. So let me just open my slide. Okay. Hello.
I had a doubt regarding the previous assignment.
Yes, please ask.
Hello, sir. I had a doubt regarding the previous
Yes, please
assignment.
ask. Yes, ask.
Sir, the problem type of questions in the assignment 1 and assignment 2. Sir, can you please share the steps of that problem solving
Which
session of
problem?
assignment 1 and assignment 2?
Which problem?
In the first problem of assignment 1 and same the first problem of assignment 2.
Okay. So what can you show me the problem? Because see, we have instructed that we cannot solve the question of your given assignments, right? We should take the pattern of the question.
Sir, only after. Yes, sir.
What?
Sir, after publishing the answers, then can you share the steps? Means how that can be solved?
So is it like they are not sharing?
No, only the answer is given, not the steps and how that was solving. It was not
So
given.
what was the question?
Actually, sir,
Uh,
I also had a doubt about the same question. So, in that, I mean, the method was straightforward, but we couldn't, I mean, write the answer. So, the question was calculate the reaction rate constant for Buckminster fullerene to diamond conversion at 300 K, 1 atmosphere, and the energies of formation of C60 and diamond were given. So, actually, the formula to solve the question was included in the lectures for the week. So, we could solve that. But the answer was coming to be e raised to the power 910 or something. And so, that value is so big that we couldn't calculate it on the calculator. And that's why we couldn't enter it in the chat box, because if we were typing e raised to that answer, then it was not accepting that value. And then the correct answer, so the accepted answers, like the assignment is graded now, see the accepted answers are given to be 910 to 915. So it was not clear that we were just supposed to write the power and not the
Okay.
value.
So it's, I think, energy of formation of diamond minus energy of formation of your fullerene
Yeah.
divided by RT.
Yeah.
Am I right?
Yes.
So could you, I mean, have you tried by using this formula?
I have tried, but so I was actually checking from the notes, and I was confused of whether we have to use the formula where we raise it to the power, e raised to the power, to calculate the.
Yes, actually it's energy. So I think you just check by both the methods, so that you can verify that by using either e raised to the power you are getting a right answer, or without using that.
So we have to not use e raised to the power.
Okay, so then probably you should not use that because it's just a energy of formation of diamond minus energy of formation of your fullerene divided by RT. As far as I know, because I do not have the this the value of the energy of formation, but I do have the formula of the concepts. I mean,
Okay.
so just check with that, or either maybe you could ask in the forum also.
Okay.
Probably the other TAs or the professor itself, they can reply for your concerned doubts.
Okay. I will check by the notes once again and then I'll see.
Sure, sure, sure.
Okay. Thank you.
Yeah. So okay. So as per our last lectures, we have, I have said that before coming to the class, at least you should watch 3 to 4 lectures. So how many lectures have you watched so that I can go ahead accordingly? This is week 3. How many have you attempted? How many lectures?
So the two of them completed.
Okay. What about the other one?
I watched the third one half.
Okay. Because why I'm saying is so that we all can be on the same page. Okay. If I'll be
Yes.
explaining and you will be misleaded, then it won't make any sense. So that's the main agenda of watching lectures prior coming to the class. I have also mentioned in my very first class. So probably I think you guys have missed that class. So I have instructed all. So anyways, let's see what today I have collected, what kind of a question. So do you know the pattern how we go for our lecture? Have you attended the very first class?
No, sir.
No? Okay.
No.
Okay. Yeah. So let me share my screen. Mm, so can you see the screen?
Yes, sir.
Yes, sir.
Oh, fine. So okay. Let's begin again. I'll give you a very brief because I have already given my introduction and all. So this is our course, and we have reached to the week 3 of carbon materials and manufacturing. I am Saurabh Soni, and I'll be taking your doubt and some problems for this sessions week by week, every week on Tuesday in the same time. And we'll try to cover as many as question as possible. That could be uh, I mean. Um, that could make your assignments easy to solve. Okay. You want My job is to make you guys comfortable so that you can attempt a question and you can score good in your assignments. Okay. So but I cannot take exactly the same question, but I'll try to take some relevant questions which can be helpful for your assignments as well as the concepts clearance. So how we go in this session is usually I throw a question, then you have to give the answers, and you have either, if you can't, then you have to guess, because I want to make this session interactive. It's not just I'm the teaching and you are just listening and watching the slides. It's not like that. You have to participate. So that's the main reason I always suggest to watch at least 3 to 4 lectures so that you can participate in the discussion. Otherwise, if you have not watched, then it's it's worthless, because I cannot then discuss with you guys. Okay. So instead of monologue, I want to make it as a interaction as well as a conversation between me and all the students. Okay. Am I clear?
Yes, sir.
Okay.
Yes, sir.
Okay, yeah. So let's begin with our today's very first question. So the question is asking is two main parameters that determine the quality of graphite ore are crystal size and purity, La and
Yes, sir.
LC, crystal size and manufacturability, compatibility with froth flotation.
Sir, option A.
Option A. Okay, what about others? Please, you don't need to fear or it could be wrong, right? Anything. I mean, I just want you guys to participate and just utilize your concept and brain to in your discussion. Even though if you're saying wrong, that it should have at least some why you thought that it could be the right answer. It's fine to be wrong, but I want to see that how you think and how you uh, reach to the point of your answer. So that's the main I want you to make to think more and more. And so because it's a theoretical course, we don't have enough or the ample number of numerical problem. So this is how it will be very interesting. Trust me, if we will go by this method. Okay, so one has answered, I think, A, and what about others?
So I'm not sure about the answer for this because I've not gone through this part of the lecture. So
Okay,
I'm not sure about.
okay, okay. And any other? I think one more student is also there. Let me just check. Uh, Pooja, can you?
I just now said that
Okay,
I
okay.
am.
So who? Sunisha.
No, sir.
Sir, I said answer A. But it is in the fourth class, but I didn't went to the class, but I guessed the answer. Sorry, sir.
And so Ashmi did not guess or answer.
Yeah, yes, sir. I am
Okay,
confused with A and C.
okay, okay. Okay, so at least you should speak why you're thinking and why is it so. Then it's fine. I mean, I just want you guys to speak and be comfortable in the class. It's not just, otherwise it's very boring and difficult to teach in online sessions. Okay, so it's fine. So be habituated to answer and speak in the class. So what this question is asking, two main parameters that determine the quality of graphite ore. So any kind of a ore when you will take, then what are the two main parameters? There are plenty of parameters, but what are the two parameters which can define the quality? Okay, so when you see the slide, so all the concepts I'll be taking from your lecture notes only. I won't take from any other materials, because so that you can correlate with that. So in this slide, when you will see, it's explaining about the engineering carbon. So in the very first grade is your natural graphite. Graphite is very well known for the various application. Now I should say the generation is more on the graphite, graphene, this kind of a material, because these materials are showing a very exotic kind of a property and utilizing in so many applications. uh, I mean range of application, because of its very specific properties and the qualities. So for that, your qualities of the graphite ore should be very good. So when you will see the engineering carbon, so what is this? Carbon material used in large scale manufacturing. Okay, now this excludes micro nanocarbon structure materials. This carbon manufacturing, when you will see, it has a two aspects. The first one is the processing, okay, or you can say the material itself, how you can make the material. Second is making a structural component. So after when you make the material, the second part is You can make a device using those material, or you can make some structural components depending upon the applications you are focusing on. Now, the example of engineering carbon is your graphite. Okay, so graphite is available in the natural form also, and in many lab scales or industrial grade scale, you can synthesize this also. Granular porous carbon. Okay, some carbons are your porous carbon, so this has some different applications. That why we use a porous carbon. Activated carbon, maybe you have heard, and you might not have heard about this. Carbon black is very well known. Glass like carbon, it is also very well known. Carbon fibers we have maybe seen because of its very good property, mechanical and all. Carbon resin composites, carbon carbon composites, and so many engineering carbons are there. Now, the natural graphite mineral is found in metamorphic sedimentary rocks. Okay, so I have said like there are two kind of graphite, natural and the synthetic. So the natural one, so there are a different kind of rocks. You have if you are from metallurgy background, you have studied that the types of rocks, metamorphic and all. So it is found in basically in the metamorphic sedimentary rocks, and it is embedded in the mica, marble or quartzite in elemental form with impurities. So you have to extract this and process that so that you can get the graphite mineral, isn't it? Now, the metamorphic rock is a rock that has transformed into another due to high pressure and temperature. Okay, so this is your metamorphic rock which has transformed into another form due to high pressure and temperature, which is built inside our earth. It is also formed by thermal metamorphism in coal stream, and it is formed by removal of non-carbon atoms from the organic material under extreme conditions. Now, the graphite ores are classified based on impurities and crystallite size. Okay, so these are the classification on the basis of impurities and crystallite size. So, it is what this is asking, parameters. So now here we got crystallite size, so A, and the purity. So India produces at least 15 to 20% of world's graphite. Himalayan graphite is known for its large crystal. This is of high interest of geologists. So here the answer will be our crystallite size and the purity is the two main parameters that we should look upon when we are considering the graphite ore for a better and the best quality. Now is it making sense somewhat?
Yeah.
Yes,
Yes,
sir.
sir.
Okay. So these are kind of a little bit history you can say about the graphite. Okay. Now the second question is a Berger vectors indicates what? Can you now guess or yes Pooja, you said something. You can unmute and you can speak. Do you want to say something? Okay. Yeah, so if you're facing a network issue, you can type you can in the chat box. It's also fine. I can see from there. And others who have a good network, they can say unmute and they can say.
Sir, option C.
Okay. The location and angle of a dislocation. And others?
Sir, I had a confusion of option B and C.
Okay.
Sir, maybe
So
option D.
option D.
B.
B. Okay. So those who said why you said option B, can you please elaborate, or do you know something about it a little bit? And you can say something.
Sir, it says about the lattice distortion. Sir, I,
Okay.
that's why I chose the So it is it happens
Sir, a Berger's vector can tell us about like it can tell us what kind of line defect is present,
that
and maybe because it is a vector, it can also tell us about the magnitude.
Okay.
dislocation. Um, so I'm not fully clear about that topic.
Okay. Okay. So let's see. So when you will see about the graphite, it has about the rhombohedral graphite, which has a rhombohedral structure. So is a metastable state, and the hexagonal graphite is thermodynamically stable state. So this Rg is always found along with Hg in nature. So this hexagonal, the corner atom of layer B is at the center of A. In rhombohedral, it is displayed by some degree. Okay, so here you can say it is displaced, and here the corner atom of layer B. So here this is the corner atom of layer B is at the center. See, here you can see at the center of A. Now, up to 25% of natural graphite may have rhombohedral structure. Graphite almost never has AA structure due to prohibitive energies. So this Rg is often considered in a stacking fault since it can form by glide or twinning. Okay, so this is because of the graphite basal plane is the main glide plane. Now the basal dislocation are more common in graphite. Basal dislocation means Berger vector parallel to the basal plane, which is basal dislocation. So Berger vector is what? Which represent the direction and the magnitude of the dislocation, that where it is dislocating. So when you will see here, it is indicating like this. So where it is dislocating, so the direction as well as the magnitude of the dislocation, its value remains constant at all points of the dislocation line. So this rhombohedral graphite mainly studied for defects in graphite, but has also been proposed as a graphite with optimum angular spread for certain applications such as superconductivity. It's electrically thermally conductive and anisotropic. Okay, so mainly the Berger vector indicates the magnitude and what? Direction, or you can say the angle of the dislocation. So this was the B was the right answer. So this is your Berger vector. So this is like a theoretical question. Maybe you have studied in your mechanical metallurgy. Now, the area of a graphite crystallite is measured in the form of what? Yes, what will be the answer?
Sir, diameter of an equivalent sphere.
Okay. Why?
I don't know, sir. I remember something from the lecture.
Okay. What about other?
Sir, diameter of sphere.
Okay, why?
Sir, the crystal that size is in a three-dimensional, so that's why sphere. Uh, Sorry if I'm wrong.
Hmm.
Sir, as in a three-dimensional space, it is measured.
Okay.
So that's why.
Hmm. So why can't it could be a radius? Why it is, if we are considering the 3D, then why it is diameter? Why can't it measures in the form of radius?
Sir, usually crystallite size are measured in form of diameter itself for easier comparisons and um,
Hmm. Okay. Okay, let's see what it will be. What it would be. Um, so here when you will see this slide about, it is explaining the graphite crystal, where the natural graphite exists in two crystallographic form, as I mentioned in our previous question: hexagonal Hg graphite and rhombohedral Rg graphite. So hexagonal graphite, it is hexagonal crystal but does not feature the closest packing. Layers are separated with an offset. Okay. In ideal SCP, the C value, this is your C, equals to 1.633 A. In graphite, it is, in ideal SCP it is like this, but in graphite it is 2.723 A due to unhybridized p orbital or electron cloud. Now the unit cell constant A in here, it is 0.245 nanometer. This is A value, and the C value, this is 0.670 nanometer. Separation between the AB. AB is how much? 0.335 nanometer. Now the bond length between adjacent carbon atom is 0.142 nanometer. So these are some factual. This is a space group and this is stable up to 2600 Kelvin. Properties of graphite and are anisotropic. For example, it has two thermal expansion coefficient parallel to the C axis, parallel to the A axis. Important crystal parameters La and Lc. La is what? Crystallite diameter, and Lc is stack thickness, are length values along A axis, basal plane and C axis of the crystal. So La is measured in the terms of diameter of an equivalent sphere. Okay, so when you will see, it won't measure in the form of circle, as you mentioned somebody, because of its 3D, it's measured in the form of sphere. It is not radius, not anything else, but it is diameter of an equivalent sphere. So here, how many carbon atoms do we have in graphite unit cell? Okay, this can be asked as a question. So you should know that how to calculate the number of atoms in the unit cell. Okay, so these are saying about which we will further discuss also. So about the this. So the diameter of an equivalent sphere. So somebody was right that they have mentioned the diameter of equivalent sphere. Now, the rhombohedral graphite has the following layer arrangement in the crystal. So which arrangement you will see in the rhombohedral RG graphite?
Sir, I didn't heard the lecture. That's why.
Okay. And what about others?
Sir, is that option C?
Let's see. Again, the same slide, you can see the rhombohedral, how it is. Now, can you tell?
Sir, option C.
Okay. So, what about others who has not watched the lecture? Now, can you tell me? Hello, yes, I'm waiting. So I think somebody answered, one has answered and another has not answered. So now can you answer this? Hello.
Sir, I answered A, B, C, A. Option C.
And one more, there is one more student. Who has answered and who has not answered?
Sir, I had answered.
Okay, what about Ashmi? Ashmi, are you there in the class? Or you just joined and left the class? Hello. Can you please
Yes, sir,
answer?
I'm there.
Yeah, so can you please answer now? Or do you want to see the question? This is the question.
Yes, sir, I know, but I've not understood the rhomboidal graphite wala part, so I'm going to watch that again.
So now can you see the diagram, and it is very very simple. You can just read, you have to just read what it is asking. You can easily answer. Just see the diagram.
ABC, ABC.
Yes. In hexagonal it is forming ABAB. Okay. But in rhombohedral ABC, again when it comes to A, it is coming same to the after C, same A is coming. Then again it will go ABC ABC. In hexagonal it is ABAB. Okay. So ABC ABC.
Yes, sir.
Now during a graphite rod manufacturing using needle coke, the pores can be filled using what? Maybe it is very application oriented question, so you you might have seen during the road formation that what they usually fill. It is very simple. Can you guess?
Sir, is that resin?
Yes. Which kind of a resin?
Sir, that I'm not sure.
Okay. What about other?
Sir, high viscosity resin.
Okay. So you can see this pore filling part. Okay, so they are asking about this material, this blue. So which is what? So here we will understand the mechanism. Graphite from needle coke. So this is your needle coke in diagram very first. So grains of needle tar pitch coke are used with a binder for manufacturing purpose. So here binder. Here we will take the coke particles plus resin. So this binder resin with high viscosity and ability to harden due to cross-linking, it can be resin or pitch. The mixture of binder and graphite particles can be given a shape. Example by extrusion, molding, isostatic pressing, further heat treated. Further details on coke pitch processing will be covered under the raw material section. Okay, so these are some definitions like burning. Burning is what? Heating in the presence of oxygen. Calcination is heating in the presence or the limited supply of oxygen, occasionally also in air. Pyrolysis heating under an inert atmosphere. So they will make a high viscosity resin and then heat, then carbonized sample, then again the pore filling, then heat and the graphite sample, and then finally you will get some manufacture or the in the form of some structure by using casting, molding or the pressing or the extrusion. So this is what high viscosity resin. Okay, pores can be filled using what? High viscosity resin. Now again the same question from the last slide. Needle coke is what?
Sir, option A.
Okay.
Sir, I am very sorry, but I have to leave this session because I'm still at my internship and I
Okay,
will
okay,
have to
okay,
go
okay.
home now.
Okay, okay, no worries.
Okay, I'll join from the next session after
Yeah,
going
yeah,
home
sure,
only.
sure, sure.
Yes, thank you,
No
sir.
problem. Yeah. Yes. So actually these lectures are also available in the, I mean the in YouTube. So if you cannot attend, you can join or you can watch this lecture later also. So this, I mean, I upload for your, I mean, if for those who cannot attend the session.
Thank you, sir. The previous two lectures I couldn't attend.
Yeah, yeah, you
Um,
can also, I mean, if you cannot join or either the students are there or not, that doesn't matter. I will take as many question as question as possible, and used to upload the lecture so that everybody can benefit out of it.
Yes, sir. Is that in YouTube channel or through the NPTL that
I
Swayam
think
portal itself?
NPTEL team will share the YouTube channel so that you can watch it from there. After the class, I usually upload.
Yes, sir. Thank you.
Yeah. So if you wanna also, I mean, if you wanna leave, if you have work, then it's not a problem. I will take the class, and you can also later watch the lecture from there.
Sir, now I am okay to attend, sir. Previous time I was in work. Now I am totally okay to attend.
Okay. Yeah. Yeah. So here, this is your so needle coke is what you are in the fifth line. You can see the coke is pre-treated to produce needle coke, which is used as a graphite precursor. Okay, so this needle coke is used as a graphite precursor. So if all non-carbon atoms are removed from hydrocarbon, carbons can be obtained. Okay. Some natural materials are high in carbon content, but in the form of hydrocarbons and with impurities. These are common residuals of petrochemical refining. Example, coke, coal tar, pitch. Coke is non-graphitic solid which is graphitizable, can be converted to graphite also. And this needle coke is used as a precursor for graphite, which is nothing but the pre-treated coke. So coke can also be derived from coal tar pitch, and coal tar pitch is very high viscosity liquid obtained as a residue after distillation of coal tar. There are other types of pitches. All of them contain a complex mixture of aromatic and aliphatic hydrocarbons. Example, mesophase pitch, mesogenic pitch, petroleum, isotropic pitch. Damar used for road construction is classified as pitch. So these pitches are used for making carbon fiber. So in the image you can see the calcined petroleum coke and coal tar pitch, and these are the pitch. So some definitions: mesophase pitch means contains optically detectable spheres of anisotropic graphite-like structure, which has a melting point of 300 degrees centigrade, and the isotropic pitch does not feature any graphitic-like structure. Okay, so your pre-treated coke is needle coke. Now, in the froth flotation process, impurities are separated based on what?
Sir, option A is the answer.
Option A. Okay.
Sir, in between some network problems, that's why.
Why option A?
Sir, I read that it is based on that. Um, Sir, 1 minute. I will think once more.
Okay. Yeah, you can think, not an issue.
Sir, I am confused with that answer.
Okay. So what? Which answer you are confusing? Between which?
Sir, is that the hydrophilicity? Is that the right answer?
Froth flotation is very well known technique, And now can you just see, and now can you guess the answer?
Sir, I don't remember. It is wetting process like. Uh, Sir, it is the hydrophilic nature due to that.
Huh?
Sir, option B is the answer.
Okay. Now can you, by seeing this slide, now can you try to explain that what is happening? Maybe you might have, are you undergrad student or a master's?
Sir,
You're a BTech student?
sir, I'm just completed masters and joined.
Huh?
No, MSc.
MSc,
I just
okay.
completed my MSc and joined. Just completed my MSc.
Okay. In which
Sir,
discipline?
actually, I'm from physics background. So that's why I didn't have no much knowledge about these things.
Okay. 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 Yeah. No, it's not an issue. Can you just read the sixth point of this slide?
Yes, sir. By the process of this flotation, floating impurities using suitable frothing agents, separation based on hydrophilicity.
Yes. So
Sir,
separation
actually,
is based
sorry,
on
sir. It is a
hydrophilicity.
actually I heard this topic in +2 level, froth flotation process,
Yes.
mineral or separation. Sorry for not remembering that. That's why I confused between
Yeah,
that
it's
two
very
options.
simple. When we use, soaps in our +2, how we um, some stains are there in our clothes. When we apply a soap, then how it can remove? I mean, there is some thing. Na? So here also we make a froth so that we can separate. So in froth flotation by using a hydrophilicity, if air bubbles are passed through a suspension, the hydrophobic impurity. So the impurity which are hydrophobic in nature will get attached to the bubble and float. Isn't it?
Yes, sir. It's very clear.
Yeah.
Sorry, sir.
And the frothing agent, what we can use to form a bubble? Soaps, sodium laureth sulfate, sodium laureth and some also there are some something related to the soap, some something chemical like that. So these are the things that we use. Okay.
Yes, sir.
Okay.
Thank you.
Now, which of the following are types of natural graphite ore? I have explained the graphite ore, sorry, natural graphite ore. So maybe you have heard or you might have seen somewhere that which are the kind of this natural graphite ore.
Sir, is that option C?
No, here the answer is more than one. This is your hint.
Sir, option C and D. Sir, option C and D.
C and D or B? You are saying B or D?
Option C and option D, amorphous and flake.
Okay, amorphous and flake. Okay. Are you sure?
Sir,
Just think.
in case of flake, option C, I am sure. Sir, also option C, I am sure. Option B and D, I have a confusion. Vein and amorphous. Sir, can it be three correct answers or two?
Maybe you can pick 3 also.
Then option B, C, and D.
Okay. Except answer A. You are
Yes, sir,
saying.
except A.
Okay. Let's see. So are you right or wrong?
Sir, I think I'm right from this slide.
Yes. You are right.
Thank you, sir.
Here, the first one is your vein. Vein is what? Lump graphite. It has a large crystal. Flake graphite, medium crystal. Amorphous graphite, powder containing very small crystal. So these are the 3 type of graphite. Very simple. Okay.
Yes, sir.
Vein, flake and amorphous. Now, this is again the same question. Which of the following is true about the rhombohedral graphite? Just now we have discussed.
Sir, option B, I'm sure. Um, but option. Sir,
Just
option
think,
B
think.
and D.
Option B and
D.
B and
Sir, option B and D.
okay. Are you sure?
Sir, 1 minute.
Yeah, you can think.
Sir, option B and C. B and C.
Okay. Now can you comment on this?
Sir, option C. B and C. It is gliding of the planes. Sir, am I right?
Yes, you are right. Because it is formed due to gliding of hexagonal graphite basal plane. This is hexagonal. When this will glide, you will find rhombohedral. Okay?
Yes, sir. Yes, sir.
Yes. We can perform casting of molten graphite to give it required shape. Is it true or false? Just think.
Sir, false option. Not true.
Why?
Sorry. Sir, it is molten. So, sorry, sir. It is true actually. I thought it is solid.
Why?
Sir, it is molten and it is actually flex. It is due to have a flexibility, so it can. Mm.
True or false?
Sir, it's true.
Why?
Sir, it is due to its properties. Mm, Sir, I have no much points to explain. That's why.
Okay, no problem. Actually, it is false. Okay, we cannot perform the casting of molten graphite. Okay, that you have to, I'm leaving it for you. Just listen to the lecture because there is a reason. I not explaining the reason. I know, but just it has explained in the class. Okay, just listen to that carefully. Okay, and I will ask in the next class why it is so.
Yes, sir. I will attend it carefully.
Yes. Graphite has SCP crystal structure, true or false?
Sir, true is
We have discussed it.
sir, HCP and rhombohedral both.
Yes, here it is, right? So it is false. It is not a hexagonal closed pack. It is hexagonal graphite. It is asking hexagonal closed pack crystal structure. No, it is false. It is not hexagonal closed pack. It is hexagonal graphite. It is somewhere deviated from the ideal SCP. Okay.
Okay, sir.
Is it impossible to have edge and screw dislocation in hexagonal graphite?
Sir, I am not sure about this.
Okay. So I will also suggest you for this. This is available in this slide to watch it carefully. So here it is saying weaker links can also be lead to non-vessel faults, and they are saying the screw and the edge dislocations are also possibles here. This is 60-degree vessel dislocation in graphite, and this is your screw dislocation in graphite. So this is what it is saying impossible, but no, it is possible. So that's why it is false. Himalayan graphite is known as the large size of graphite crystallites. This I have, I think in some slide I said about this. True or false? Yes. So it was, I have explained like a true. Hello.
Sir, sir, I didn't heard that previous question.
So can you answer this?
Sir, I'm not sure.
We said na it is true. This is explained in this slide where it was no here. Somewhere it was written in this slide I have explained. Yeah, Himalayan graphite is known for its large crystal. Okay, so it is true.
Sir, I said that answer in between some network problems, and I couldn't type also. That's why.
Okay. Now can you answer heat treatment of certain
Uh,
polymers
this
can yield?
this question, sir, I'm not sure about the answer. Um,
Okay. So this is synthetic graphite. So this is heat treatment of pre-processed petrochemicals. Precipitation during the steel making is grease graphite. Heat treatment of polymers, which is nothing but the pyrolysis. Hot pressing. This is the how can we produce hot pressing of vapor deposited carbon. So in all cases, the graphite is produced in its polycrystalline form. Okay. So this is certain polymers can yield polycrystalline artificial graphite. So that's why it is true. Because in all cases, graphite is produced in its polycrystalline form, and which is what the question is asking. So all types of carbon materials are difficult to machine due to hard and brittle nature. It is challenging to give its complex shape due to anisotropy. It does not melt, so forming techniques are not useful here. And the extensive sintering or the milling can lead to the loss of the crystallinity. So what is the solution for this? To make it useful, so manufacturing with graphite is done along with the material preparation, which is the solution. Now the graphite precursor are milled to microscale particles and mixed with a binder, and binder is also converted into graphitic carbon via the heat treatment process. Some carbon materials or precursors are not graphite but are graphitic or graphitizing. So graphite is a semi-metal. Semi-metal has very small or no overlap between the conduction band and the valence band. This is, you can say. Okay, in case of graphite, the valence band is filled and it touches the empty conduction band at the Fermi level in case of graphite. So isotropic pitch can yield highly crystalline graphite compared to mesophase pitch. True or false?
Sir, true.
This is the same slide which I explained, right? So here, isotropic pitch can yield high crystalline graphite. So this is your, then the mesophase pitch. So mesophase pitch contains optically detectable spheres of anisotropic graphite-like structure, does not feature any graphitic-like crystal. So which is false because it does not have any graphitic-like features. Okay, and it is saying that yield highly crystalline graphite. So but it does not feature any graphitic-like structure. That's why it is false. Okay.
Sir, both the isotropic and meso, that both are not possible to make.
No, in mesophase it contains the anisotropic graphite-like structure, but in isotropic pitch it does not.
Okay, sir. Okay.
Yes. Okay. So these are the some questions. Hope that will be helpful for your assignments. And so we'll meet in our next class. But before coming to the next class, please pause the lecture.
Sure, sir. Thank you.
Okay. Yeah.
Thank you, sir.
Yeah.